Can artificial intelligence help us make smarter trade decisions in a world driven by tariffs, geopolitics, and economic uncertainty? Welcome to a fresh new episode of XTraw AI, coming to you right after a buzzing and action-packed SAP Sapphire Week, where AI was everywhere from keynotes to customer conversations. And now we're taking that momentum forward, diving into the economics of AI and how it could reshape one of the most misunderstood levers of global commerce, tariffs. I'm your host, Raghu Banda, and this is where we extract the raw, unfiltered ideas shaping the future of AI. Today's guest, he's not just a machine learning expert, he's a physicist turned AI mathematician, a truth seeker behind the performance of deep learning models, and a thought leader helping us demystify complexity with data. Joining us is Dr. Charles H. Martin, founder of Calculation Consulting and creator of WeightWatcher.ai, a powerful diagnostic tool that helps us understand why some AI models perform better than others and how we can trust them more. In this episode, we'll explore how AI can bring transparency and predictability to the chaotic world of global trade. Can models built to optimize neural networks also optimize economic strategies? Can we use AI to detect inefficiencies, correct trade bias, and even improve tariff policy? Let's find out.
So today I have a very interesting conversation. I know the whole world is talking about tariffs. And I'm here with a guest who has a bit of a background on global trade and algorithms. He's a mathematician, a data scientist as well. So the topic today is about AI versus tariffs. Can realistically algorithms rewrite global trade? So in this context, I'm inviting Charles Martin. Welcome on board, Charles.
Hey, nice to meet you. Thanks for having me.
Thanks, Charles. I know you are not only a data scientist, but also a mathematician who's made some deep inroads into the field of AI and AI optimization. Could you give us a bit of your background, a personal or a professional story?
Sure. So I actually have a background in theoretical chemistry. I did my PhD in theoretical chemistry in Chicago in the 90s. You may know one of my more famous group mates, John Jumper, who just won the Nobel Prize for developing AlphaFold. Mm-hmm. So I was in a research group that was very much focused on doing very innovative science. I then did a postdoctoral work at Champaign-Urbana. I was an NSF postdoc, one of two in the country, and I worked with someone else you may know, Jürgen Schmidhuber. Mm-hmm. He actually had two PhD advisors, and I did my PhD under one. He had one who was a theoretical physicist, and I was in the theoretical physics and chemistry group for that PhD advisor that he had. So we were doing statistical mechanics of neural networks and running neural networks on supercomputers, way back in the mid 90s. Mm-hmm. So I've been doing this a very, very long time. So, I have background in theoretical. I have an undergraduate degrees in chemistry and math, and I did a lot of physics. So I've been doing this for a very, very long time. And, it's very exciting because, about 10, 15 years ago, this stuff really started picking up steam. And it came back. Like, who would imagine all these neural networks would come back? But they came back. It's been an exciting time to see the world change.
Beautiful. I know you got a whole lot of background in academics and mathematics and mathematical physics. So I know now all the things are coming back, and now in the context of AI, and of course, you're also one of the strongest proponents of explainable AI, particularly in deep learning. So maybe could you give us a quick background or a quick look into how your framework of WeightWatcher came into existence? I know I already brought up WeightWatcher. I know that is one of your startup. I think maybe you want to talk a bit about that.
So, WeightWatcher is an open source tool I invented to provide data-free diagnostics for deep learning. And what it allows you to do is you can analyze any deep learning model that you've trained or you fine-tuned, and it can tell you how well the layers will perform. Like, have the layers converged or not? Did you overfit the data? Did you underfit the data, et cetera? And it's a tool. And also, there's a broad, very deep theory behind it, using some fairly maybe it's called esoteric techniques from theoretical physics that allows you to analyze the convergence properties of the model. And the key idea is that, when you train a neural network, you typically think about the neural network converging to some state. You put some data into it, it converges. You can predict things. But the network consists of a bunch of layers,
Hmm.
and each layer has a weight matrix, kind of like a stack of pancakes, or a cake. Like it's a layered cake. And what you want is not only do you want the whole model to converge, but each of the individual layers should converge. And the theory says how the layers converge. And it provides mechanisms for detecting if they've converged or not and how to accelerate convergence. So you can think of it sort of as, you're baking a multi-layer cake. If the temperature on the oven is too hot, you'll burn the bottom but the middle section may not get cooked. And then that's kind of what happens in a lot of AI models, that we see that some of the layers are overfit sort of near the data. And then as you train it, a lot of the layers are underfit because
Hmm.
basically you haven't baked it properly. You're not getting good convection in the oven. The heat's not moving from one layer to the other. And so the theory it solves this problem. And and it's something I've been working on for many, many years, sort of informally with an old friend at UC Berkeley and a lot of my own, and a couple of interns who've worked with me. And we've developed a general purpose theory which allows you to monitor a deep neural network as you're training it or fine tuning it, and to accelerate convergence. That's the idea.
Good.
And I think it's fairly unique. I think it's probably the only tool like it out there, and probably the only theoretical approach I'm aware of that allows you to study the convergence properties of a model layer by layer.
Okay. Great. Great. I think we'll go into a bit of that details into that a bit later. But before getting in here, with I would like to go into maybe into today's topic of tariffs, right? I think from your, I think we see a lot of talk around AI and generative AI, and for folks like you and folks like me, I also worked in the past on some of these deep learning techniques. So now, when all these things are happening, we see that uh, things are now even made available and make even understandable for the common man in nice little terms with all this new generative AI stuff happening. So now, when we apply this to different facets of life, whether it is economies or world trade or policies, things change quite a bit, or if they are used in the right way. So, from your vantage point, I know AI is transforming these traditional economic tools. Maybe take the examples of tariff modeling or trade policy simulation. What are your thoughts on that, coming from this huge background of mathematics and data science?
Well, look, I think there are tremendous opportunities to accelerate this. I used to work as a quant at BlackRock. I was a consultant at BlackRock, and this is 2010, many many years ago,
Mhm.
and started pioneering the use of AI, very primitive AI, natural language processing, to predict supply chain flows, and how companies would interact with each other. Because you had a big BlackRock, BGI. I was in the SAE group, which is the group that predicts how the market's going to move.
Mhm.
And you could predict how stock prices uh, were going to move, or how you might want to reallocate a portfolio based on the interactions between companies. So you'd like to understand, does how does one company's description of what they do affect the price of another company? If Amazon all of a sudden decides they want to start selling dog food,
Mhm.
then Amazon has very small margins, and
Right.
so the dog food companies are going to get scared because they can't compete. And I think you start looking, we had many many models like this that would study supply chains, because if you're going to build portfolios of the market and trade on the market, you need to understand supply chain factors. And of course, what's happening with tariffs is that it's a massive strike to
Mhm.
all the global supply chains. And what you need to understand is how to interpret how these tariffs are going to affect the supply chains of a major company. Now, you might have, for example, very, very large, complex tariff rulings that you can feed into an LLM. So if you have very, very complex legal constructs, these can be fed into LLMs, and the LLMs can understand them and turn them into machine readable summaries in a matter of minutes. It might take a human weeks to do this, but the LLM can understand immediately where the tariffs are going to go. You also are going to have graph neural networks. Now you can imagine you have a graph neural network or a graph model. I mean, had such graph models, before. It's similar models, of course, 15 years ago, 10 years ago. But you have very complex graph neural networks. You can model every port, every factory, every supplier as nodes in a living supply chain map. And that means we could example, say there's a 20% duty on nickel. You could see how that nickel is going to, that duty is going to reverberate through prices of batteries, and how the price of batteries might infect autos, and how the price of autos might infect insurance premiums. So you want to understand the flow, and you can use graph neural networks and other graph models to understand how tariffs on specific products are going to impact the supply chains of companies downstream. And then of course what you want to do is you want to do what if scenarios, right? You want to test, well, what if we do this, or what if this happens? And so you have reinforcement learning algorithms now that allow you to test millions of what if scenarios, and you can almost do this overnight. So you can surface policy options that can balance jobs and consumer prices, and maybe even more abstract things like climate goals. So you have basically both large firms and large governments don't have to wait weeks and weeks and weeks to grasp the impact of a tariff. They can get an interactive view immediately of what's going on. And I think that's where the AI has a tremendous impact on what we're seeing today.
Beautiful. So in this context, I know you have been recently posted something about like the market being algorithmically driven.
Yeah, oh, absolutely.
Could you expand on that? How it applies to tariffs and the global pricing market as well?
Absolutely, Chris. I'm sort of taking a little bit from a trading perspective, because I've worked in large hedge funds, I've worked in small hedge funds, doing long short trading, or doing options pricing, and so you have sort of a stack of sort of like just like in software, there's a computer stack. There's the IP stack. You have a stack in the markets that determine how basically how the markets are algorithmically driven. So, at the very fast level, you have market data bots and high frequency traders who are repricing commodities and futures in a matter of milliseconds. And these are the same guys who made DeepSeek, right? These super brilliant HFT guys who will do this. But then you're going to have, people who are doing long short strategies to try to reprice on a slower time scale, maybe, daily or weekly. And then you have large portfolios that are, a place like BlackRock that is reallocating their portfolio on a quarterly basis. And they're trying to understand the impact of these supply chains. And then of the tariffs and how they affect the supply chains. But then, of course, you have the companies themselves, and they're going to have logistic platforms, right? You're going to have, if you might find out that there's tariffs in China, you need to all of a sudden reroute containers coming from China, maybe from Vietnam, because you're trying to get a cheaper price. And they're going to have to look broadly at logistics of all their supply chain and being able to update, container shipments, landing costs. They're going to have to notify their procurement teams to change things. This has to be done within very, very quickly to avoid massive market impacts, and also just to really keep track of the constant changing framework. You're going to have corporate planning suites. They're going to have to run weekly what if scenarios to suggest alternative suppliers and look for demand across different regions. And then of course you have pricing engines, right? How do you price this stuff? People think that tariffs are going to somehow increase the prices on everything, but the role of a company, and you take a basic economics class, is to change their supply chains and their pricing to reflect the markets. So it's not, I don't think that necessarily massive tariffs are going, I mean, obviously, if we stop importing everything from China, things could change. But, in terms of tariffs broadly, companies are able to restructure their supply chains, reassess demand, and to reassess pricing to adjust for the tariffs. And that's where this is where AI comes in to help doing all these things.
So this is where I think when you do these tariff calculations, or maybe how can you bring transparency while you're doing these kind of tariff calculations, or
absolutely
even making the decision making? while doing
Well,
this
this
global
is
trade?
where why I invented Weight Watcher is to
Mhm.
try to get some insight into what's happening when you modify these models. Of course, there are lots of models. There are traditional logistic regression type models. Basic or econometric models that people use, and many of these are generalized linear models that people use. And from there, you try to make models that you can interpret exactly what's going on. And those are things you might see in like medical diagnosis. Because if you're trying to diagnose a problem, you need to know exactly what's happening. And so these models can be brought to bear. More sophisticated problems, people use XGBoost type models, and
Mhm.
those models you're going to have shapely values, and maybe there's some controversy over how well that works, but you have to go in and try to figure out what features are going to be driving the what features are driving your predictions. And I think with more sophisticated models like AI, the question is, do you have access to the internals? If you're running something like O3 on OpenAI, you have no access internally. You just have to ask it, why did you do this? And maybe it'll tell you, maybe it will share its reasoning trace, and maybe the trace will be accurate, maybe not. Maybe it'll make it up. It's there's some people, but if you have access to the models, you can go inside it. You can apply. You can look at gradients to try group shit. You can take the kind of stuff that was developed for XGBoost models and apply it internally to the gradients, or a technology like Weight Watcher, which is trying to let you determine, did you overfit your model to the data?
Mhm.
And in fact, that's kind of where I originally came up with the idea is you work in financial modeling. And one of the big concerns you have is people tend to, you have to be very careful
Mhm.
that you're not letting the past influence the future too much.
Mhm.
You have a lot of presentation bias, and there are people doing things like, I shared a paper recently, a couple days ago on LinkedIn about people trying to use LLMs to do economic modeling. It's like, well, the LLMs have memorized, all the economic data, so you have to be very careful because it's memorized all the data. So you can't, and it knows, it has a massive presentation bias. So
Mhm.
you have to be aware of that. But there are algorithmic techniques you can use to dig inside these models and try to figure out why they're making the predictions. And again, you can run reinforcement learning scenarios to try to ask, what if you do this, what if you do that, what would happen, and use that to try to get some insight into what would be a more transparent algorithm.
Mhm. Mhm. So currently coming to this, the crisis that we are in, right? Like this global tariff crisis, and given these tariff wars going on, how how are these different economic actors missing out on not using AI models to forecast or impact more intelligently? Do you think, uh, because rather than focusing on this, do you think there is a lot more buzz going on around the crisis that might happen, or what are your thoughts about that?
Oh, absolutely. Look, you have companies. I've done consulting work with companies like
Mhm.
Walmart, internally, and I can tell you that people don't, or GoDaddy, which has the largest Hadoop store in the world, as far as we know of, and
Right.
they don't really know what's in their databases. They
Hmm.
just don't know. And have a big organization like this, and it may not have a global picture at the executive suite of where all the supply chains are, where all the demand is, where products are being, what products are going to be hit. They may not know this. And you can't just, and it's very hard even to go into the database. Let's say you want to go into a traditional database and start making queries. That's tough. There are AI systems now that can build the query systems for you to go into a large enterprise. You say, look, I want to understand how tariffs are going to affect, a certain number of supply. I'm selling a certain number of products, in Arkansas. How many of these products are coming from China? Try to trace the supply chain down. So, you can have AI tools that can help you build the queries for complex databases. I've seen systems with thousands of tables.
Hmm.
Not no, there's no one person in the organization that knows what every table does. But an AI can know that.
Hmm.
You're also going to have cases where you might have shipping manifestos, right? Or invoices that you can scan, and you can pour all these into the AI. You can get a map that you can see, and you really need to see what SKU, they call them SKUs. The what SKUs are going to be affected, which ones are going to be cut out, which ones are not. But I seriously, I'm sure people right now at a large place like Target or Walmart or Amazon, they're probably burning the midnight oil trying to figure this out, going through and writing queries and trying to do analysis. And you want to, one of the things AI does, it accelerates this kind of white collar work.
Hmm.
It's just such a tremendous accelerator to be able to do such things like this. And it's going to be critical, um, both in terms of analyzing the data you have
Mhm.
and in helping you collect data that you don't have to analyze. And
Hmm.
it's going to be, and I think it's going to be very important now because you're seeing, again, that you're going to have it's no longer an open, flat world. You know,
Okay.
the
Mhm.
world's no longer flat. It's now the barriers are going up, and you have to know how to move product through them.
So does it? Okay. So it is kind of yeah. I think you brought up an interesting point. Like it's no longer going to be a flat world. I think it's going to be, of course, depends on what kind of imports and exports that you're doing, and depending on that, the tariffs might be laid. Uh, which brings to the fact that these big corporates or the big Walmarts or the Targets or whatever companies that are using these, they might be having their economic or econometric models, whatever we call. How soon or how how
Oh,
fast they
I'm
need
sure it's
to?
already hitting them today.
Okay.
Why do you think Trump, they had him pull back on the tariffs?
Hmm.
Yeah, they're knocking on the door, begging him, don't do this. We can't respond. We don't know what to do. Look, a lot of the people who I sometimes I make some comments on the social media that are a little strong, but one thing I would say is you have a lot of people who do economic modeling or they
Hmm.
have masters in financial engineering and they're engineers, right?
Right.
And what do you learn in engineering? You learn how to solve problems other people have solved.
Right.
Somebody else has solved this problem. You're going to encounter this problem. This is the tool you use to solve that problem. It doesn't mean you're not. I mean, a lot of people are not. It's not really a creative endeavor. Of course,
Yes.
you have creative people who go into engineering, of course. But the point of the training is that you're supposed to learn. Here's the toolbox for all the problems. Here's the toolbox of tools that you use to solve for all the problems that you're going to encounter. And people hire you to know what the problems are and how to solve them quickly. Well, you're in a whole new world now because
Hmm.
this is a whole new class of problems that no one's ever solved before.
Hmm.
And the tool sets you have right now, assuming that the world is flat and you could just move things around, that's no longer the case. So the assumptions of all the existing economic forecasting models are probably all wrong. No
Hmm.
one's ever thought about what to do about this. And for sure, people are going to be banging on the door saying, look, we'll take all our tariffs off you if you don't put tariffs on us because we just have no way, we just don't know how to deal with it. And I think it's not just even about making like you not only are you not going to be able to make forecast, you're not going to be able to forecast the future.
Right.
You're going to make that's going to lead to terrible strategic decisions.
Is it?
You're
Is it?
going to have I don't even know if companies
Mhm.
can issue guidance. When you have a finance they have to go and here are our earnings and here's our guidance. How do you issue guidance if you have no idea how to make a forecast?
Hmm.
Who knows what they're going to do? So I think it's that kind of shock is not only they just don't they're going to be relying on stale that's where I think things are. It's a brand new world of economic models, and there's going to be a huge, and that's probably even worse than the fact that the tariffs are there.
Okay.
Just figuring out how to deal with them. Not that you can't, but the people who have AI and the people who are really good at creative modeling and understand are going to be the ones who win.
So this takes us to the question of how how often do you need to update your economic models?
Well, that's a question of how often do you trade or how often do you do things? Look at a
Mhm.
place like BlackRock. We were so big, right? We're so big
Right.
that you would update the model every quarter. And even a small move, we make a small move, we move the whole market. So we
Right.
have to move we have to leg in the trade. So I might come up with a way, they call it portable alpha. I come up with we get alpha and we leg that in over a few weeks. Well, during
Hmm.
the course of legging that in, everything may change. So you got a real problem. And if they move too fast, they move the whole market.
Right.
So it really depends on how big you are. Big places cannot make fast moves because people see what's happening and they front run it and get behind them. Right. So it's a huge problem. You just can't do that. Your competitors will, they'll come in, you'll die, you'll be death by 1,000 cuts.
Hmm.
So you have to move quickly, but you also have to move transparently. you don't want to be hit in a way that you're basically, prices go up on, maybe you need some particular supply that got cut off from China, and next thing you know, the supplier is going to rank up the price 100-fold,
Hmm.
right? They double it or triple it because they know you have no choice.
Hmm.
And so that's where um, you have to be able to move quickly, but you also have to, in many cases, you have to move stealthily to avoid those kinds of problems. And I think knowing what you can and can't do, what can you expose and what can you not expose?
Right, right. So I would like to take one step back and maybe try to understand what are the biggest misconceptions or misperceptions uh, that are out there when it comes to using AI in this government trade or taxation policy or
No,
tariffs.
I think that well, I think a lot of times there are
Hmm.
transparency requirements and compliance requirements, and it's not entirely clear. Let me give you an example. I was talking with a friend the other day. Like we were talking, like say I have let's say I'm working with I have a list of instructions for ChatGPT O3, and I have a long list. Maybe it's 5 pages long of things I want to give to you so you can analyze my data. But I can't give you those instructions because there's a compliance requirement,
Hmm.
right? So I have to use some sort of homomorphic encryption, or I have to share with you some open source model that I can share some of the cache. So there's some question of how you even, you may want to communicate with someone to use AI to do something, but because of the compliance and transparency requirements, you just can't do it. And that's a challenge right now because also there's also data in the model. What data are you may not be allowed to put data into an AI model. You can't just put everything into O3. I mean, we all know that anything you put in O3 is going to be an O4,
Right.
or 505, whatever the next model is. I can't keep track. O3.2 or whatever the next model will be. Whatever you put in is they're obviously going to put them into the training data, and that of course it can be extracted out. So you have to be very careful putting any kind of sensitive information into these tools. At the same time, you might want to. So this sort of mandatory transparency is a huge problem. Um, and another problem would be making things reproducible.
Hmm.
You have problems with these models, even though they're not stochastic, it is difficult to get, small changes in the inputs can cause large changes in the outputs.
Hmm.
And so reproducibility is a huge problem. Certainly anyone using AI for, say, you know, qualifying someone for credit.
Hmm.
Are you a lot kid, do you have good credit or you not have good credit? And so and if you make a mistake, that's a lawsuit. So there's these kinds of problems. Um I think that, but probably the biggest misconception is just how powerful the tools really are.
Okay.
I don't know if you've taken a look at O3 or Gemini 2.5, but they're scary good. And you have are the governments able to take all of the information they have and feed them into these AI models in a way that they can really be functional? I think that it's because it's a black box, it's difficult to trust a black box with public sector decisions. But of course, because they hallucinate,
Yeah.
right? They make stuff up. So,
Right.
so that's a challenge.
Right. Right. But I think a lot of these kind of tools are already being used globally in different government trades and different organizations.
Oh, I'm sure Elon Musk, I'm not there, but I'm sure he is pushing to get everything in the grok. I mean, just imagine putting you have all these regulations. Imagine putting all of them into an AI and all these laws and putting them into an AI and saying to the AI, okay, I want to do this.
Right.
Tell me all the things that could block me and give me scenarios that I can get around it.
Hmm.
O3 is able to do that.
Right.
I mean, it is able to do that. And the question is, how long does it take to get the data in? Is the data confidential? Do you have to train the agency to do it? How much training do you need? Things like this. But and absolutely there are companies, of course, providing, AI models for supply chain analysis and trying to understand the impact of tariffs inside companies. I did a little research for this podcast and found a few of them. I don't use them myself, but they're definitely out there.
Beautiful. Beautiful. So I would like to now kind of veer or steer our discussion into the WeightWatchers AI, your tool or your startup. maybe WeightWatchers AI or similar tools, how can they identify these different inefficiencies or biases that are in the existing tariff
Got you.
structures? Let's now
So
get into the actual real problem, right?
yes, yes. I
What?
mean, the main thing that I designed Weight Watcher to do was to solve the fine tuning problem,
Mhm.
right? The problem that people have with AI models today is that you have, if you're trying to do a very, very complex problem with thousands of examples you have to get to the model.
Right.
People are claiming, well, you can do RAG, right? That's a solution. In other words, you put all the documents into a database and you let the AI search the database.
Mhm.
You can use a long context model. People like Google claiming, oh, I can put 1 million tokens or 10 million tokens into the model and it's fine. But I think everybody knows that long context, it kind of pukes out at about 200,000 tokens. It just doesn't really work. So the problem is, how do you take an existing model, like an open source model, and fine tune it? How do you adapt it
Right.
to your problem? And this is what the DeepSeek guys really showed us, that you can do this using reinforcement learning, which is quite surprising.
Mhm.
Because 2 years ago, no one thought that would work. And so what I'm trying to do with Weight Watcher is to solve that problem, is how do you adapt the model to make sure that you're getting optimal performance and that you're not losing information when you do the adapt, that the model doesn't forget things or is doing something really minor, not doing what you want. So, you can measure, and that's what the tool is for.
Mhm.
And so one of the things we know, for example, if you're training a model and it has a very, very large instruction set, you're giving it a massive set of instructions, 10,000 instructions, 100,000 instructions to do something. And, in a government scale, that you would see that might be, the scale of what you might want to do. The model can look at the update. It looks at the fine-tune update and tell you, well, did you do it correctly? Or did you screw it up?
Mhm.
And if you screwed it up, can we fix it? And so that's what it does. So if you're doing large scale instruction fine tuning or large scale reinforcement learning, where you're really making substantive changes to the model, not just cosmetic changes, but substantive changes,
Mhm.
then we can detect whether you have done that correctly, and we can help you do it in a way that's optimal. So we can really optimize the performance of what you're trying to do. And I think that's probably, there was a report by McKinsey that said only 9% of companies are fine tuning.
Mhm.
And of that, probably I bet only 9% of those are doing something other than, parameter efficient LoRa, which is really just a cosmetic fix,
Mhm.
some small cosmetic thing. But if you're trying to get the model to really change and give you complex reasoning or complex instruction following, then Weight Watcher can help you do that.
Mhm. So, in the context of the existing tariff structures, what do you see? How can these inefficiencies or biases, how can these be handled or how can these be addressed?
Well, look, I think we're going to have to wait to see where things flush out.
Right.
Right
Right.
now, we're in a major tariff war, and hopefully, one of the things that was quite eye-opening for a lot of people is that so many other countries have tariffs on the United States products.
Right.
But you also have tariffs. You also have problems with, the claims being made of currency manipulations, claims of unfair law practices,
Mhm.
and so like I say, we're moving to a world that's not going to be flat.
Mhm.
And we know that, especially with China, we know there's a huge amount of products that just in the supply chain that it goes into. So even if you're not buying a product directly from China or sourcing it from China, probably something in your supply chain is being sourced from China.
Mhm.
And what you need to do is people are going to need to start creating sort of or using tools that have very sophisticated supply chain maps, every SKU in the world, right?
Mhm.
Because every product has a SKU.
Right.
Every SKU has some meta information about where it came from.
Mhm.
And you're going to need to have very, very complex environments that know how every product is manufactured, all the SKUs in it, the SKUs and the SKUs and the SKUs that go to those SKUs, and be able to reallocate your supply chains to compensate for the tariffs. And I think there's a company I saw a couple of them now. One called Altera.
Mhm.
I don't use them myself, right? So I can't speak to what they really are, but I think that's where things are going.
Beautiful.
And certainly that, otherwise, what are you going to do? You can't
Yeah.
just cut off what you're doing. You can't stop buying stuff and making things. So you've got to try to reallocate your supply chains. I have a list of it: Altana, Interos, Everstream, Blue Yonder, O9, Fashion. So number of AI scenario planning tools, tariff scenario planners, for example,
Okay.
that will help you understand, basically a giant knowledge graph of how all companies are linked to all other companies and how all the products they make are linked to other products.
Okay. I know we are in the middle of this pause, the 90-day pause. And of course, once this is passed over, I think we get into the real tariff structures, I think, with different countries and the different global trade. And I believe this is where you will have to, I think your work, I think, or similar work like what you guys have done on emphasizing measuring the structure of these different neural networks, right? I think this is where you have all this network of where the in a particular supply chain, where this particular product is coming in from, how much do you need to weigh this, and what is the bias of that? And then this is
Well,
where I think, yeah.
The other challenge is, look, I mean, a lot of companies have a lot of internal data. They don't want to give all this internal data to OpenAI.
Right.
They're not going to do that. Like you can't give away your entire supply chain because that supply chain is how people trade on you. Those are so how are you going to do this without building your own internal models and do it without having doing some kind of fine tuning either on LLMs or graph neural networks or something that can help you integrate your data into a model. And right now, the two choices you have are basically you have three choices. RAG, which is basically data, which is okay, but not RAG is not it's not an all-in solution.
Yeah.
Right? It's not. It's still problematic. It's just the dumb. It's the simplest thing you can do. You have Gemini, large scale models that have massive context windows, which you still have to give the data to the model. You're not running it locally. You might try to run something like a Llama 4, which appears to be might be dead in the water. You know, there are these open. You know, you could run DeepSeek if but they may make DeepSeek illegal, and or you have to fine tune a model. You have to build your own models and fine tune them. And that's really, really hard. You know, building models is hard.
Right.
Using tools is a lot easier than building from scratch. And I think that's where, again, the companies that can provide this technology and really understand it are going to be the winners here.
So post this 90-day period, I think once this tariff, I think some of these tariff structures will be redefined and some of these things will be re-strategized. Do you believe that there is going to be a huge wave of how these different AI tools can help handle these big corporations or these big supply chains? Or what are your thoughts?
It has to be. Yeah, I mean, we're already seeing them, right? People already have this. And again, we have, look, when I was at BlackRock, we had a team of like 200 engineers, 200 financial engineers and researchers. And, you know, their job was to do things like analyze supply chains. You know, if you're managing massive portfolios with hundreds and hundreds of thousands, 100 companies or 1,000 companies, you need to understand the supply chain relationships between them. So there are people doing this. Now, the question is, you know, is the government going to do it? You know, do they have the technology or the capacity to, you know, or the talent, you know, or the motivation, you know, you got to pay these people, you know, to do it. But, you know, they have many, many years of experience of analyzing supply chains. I think that companies, if they want to kind of get through this, what's happening and what appears is going to be maybe a very, very long term thing. You know, it may be that, you know, they talk about the decoupling. You know, we may have to decouple from China the way we used to be decoupled from the Soviet Union. And if that happens, that decoupling is not going to just be, you know, a clean break. It's a spider web of problems. And you're going to have tools to navigate it. And the companies aren't going to build them internal. They don't, you know, this is special. This is very, very highly specialized work, which has to be done by, you know, specialized teams, you know, teams with specific experience, both in understanding how the supply chains and tariff rules work, and understanding the AI technology.
And also global trade, right?
And global trade. Absolutely. Absolutely.
Yeah. Great. I think we are coming to this interesting juncture. I think I call this the extra AI question or the $1 billion question. If if you were to advise a government body or a trade organization, how would you build an AI framework to optimize or to recalibrate the tariff policies in real time? What are your thoughts, maybe?
No, I think that's where we'd start is with you have to first understand, you have to build a map of the entire global supply chain. You have to have this. Maybe you can there might be companies that have built this already. It's very complicated because you have to go to every single company and understand what are all your products and what do they depend on. And will they give you and can you build that for them or not? Would you have that transparency into, can you, I don't know if you can go to Walmart. I mean, when I was at Walmart, they wouldn't give me, I couldn't get access to certain databases. I'm not an employee. In cases where we're dealing with the EU, if you're not an EU citizen, you cannot get access to certain kinds of data. So there is this problem of what data does the government actually have access to? It's not like they're not, we don't live in China and we don't, our government doesn't have visibility into every company. So can you actually get visibility to this, or can you build some sort of distributed platform that can run inside a company and provide information in a way that provides the transparency you need, but doesn't expose, again, their trade secrets.
Right.
Right. And that's challenging to do. And to what extent that, I don't know if that exists, to what extent that exists, to what extent people have built it themselves. But if you're going to navigate this, I mean, the challenges you have, if you don't know how things are sourced, how do you price them?
Right.
Right. If I don't know how, if I have a cup and the cup, has some paint. I mean, these cups used to make ceramic cups in Ohio, and by hand. And then things become automated. Where does it come from? Where does the paint come from? Where does, just even something simple like that, or a pencil, where does the lead come from? Where's the paint come from? Where's the wood come from? How is it all sourced? And, how is that going to affect pricing downstream? And can you resource? And then it's very hard, I think. And, I think most people just expect the market will just sort of take care of it, by products will just reprice. But, you still have, you have commitments to, large companies have commitments to supply chains. You make agreements to buy things. So that's how do you get out of those? So and how does the government help? I think right now it's more just been. I mean, my impression is that the idea is to get everybody to take their tariffs off us,
Right.
And do business with us and stop doing business with China. That's been my sort of global view of what appears to be happening. How's that going to flush out downstream? But it's a very hard problem.
I don't know. That's a tough problem to solve, like you said. No, yeah, it's interesting. Yeah, great. I think it is a great and interesting conversation I'm having with you. I know, Charles, you've opened up some very fascinating angles between AI and economics and global trade, how they can intersect in these different ways. Any key insights that you would like to provide to our audience, or particularly maybe policy thinkers or AI practitioners, or maybe even the corporates or the big AI practitioners?
I guess probably the key insight, certainly what I got from working when I was at BlackRock doing this kind of stuff, is that there's a lot of alternative data.
Right.
And there's a lot of information in alternative data, news sources, SEC filings, tariff, whatever kinds of documents you may have internally. There's just receipts. There's a lot of alternative data, and you're going to have to really comb through all this alternative data to really try to understand what's going on. And if you want to get a fine-grained picture of it, and I don't know if whether the government really cares about a fine-grained picture. They may not have the resources or the interest, but certainly if you're a company and you're concerned about your own internal products and pricing, there's a lot of alternative data out there that you can use to try to get some economic proxies for what you're doing.
Right.
And that's a lot of what I've done in my career, is just, basically doing machine learning and AI, looking at unique kinds of data sources and trying to see what you can learn from them. And it's a combination of both having access to the data, but also understanding how to take action on the data that you have access to. What can you do with what you got?
Great. I think thanks for this amazing conversation. Any closing remarks or key insights or any top predictions that you would like to provide?
Well, you got to understand, I grew up in the Cold War. So in the Cold War, there was no interaction with the Soviets. There were no Soviet students in our graduate schools. There were no products that you built. I mean, none of these things didn't exist. And so I don't think anyone who's been sort of grown up in the last 30 years can imagine what that world is like.
Right.
But that might be where we're going. And if that's where we're going, there are going to be big changes, and it's going to and it can have really big impacts. And then maybe that's not what's going to happen. Maybe we'll work it all out. But I grew up in a very different world, so I don't know. I say the world has been flat for 30 years. I don't think it's going to be flat anymore. And so we're going to have to change the way we think about how we do any of these kind of economic forecasts and models and business models. And there's going to be a lot of innovation that's necessary.
Beautiful. Thanks for your time, Charles.
Hey, thank you.
Great background and a great thoughts.
All right. Thanks again. I look forward to listening to the podcast when it goes up. All right. Have a nice meeting you.
And there you have it. From neural nets to global markets, we've just explored a future where AI isn't just transforming models, it's rewriting the economic playbook. A massive thank you to our guest doctor, Charles H. Martin, for not only demystifying the mechanics of deep learning, but for helping us reimagine how those same principles can guide smarter, more transparent tariff policies in a volatile world. Charles, your work at WeightWatcher.ai is not only timely, but truly game-changing. And we're honored to have had you on XTraw AI. To our amazing audience, thank you for tuning in, subscribing, sharing, and being part of this growing AI-first community. If you found today's episode insightful, buckle up. We have more riveting conversations coming your way. From agentic AI to responsible AI governance, we're just getting started. Until next time, keep asking bold questions, keep exploring raw insights, and stay connected with us here at XTraw AI, where we go beyond the hype and deep into the signal. This is your host, Raghu Banda, signing off. Stay curious, stay critical. Happy predicting the future with AI technologies, and stay XTraw.